This video is going to be part 1 of solving equations with radicals and rational exponents. So we want to make sure we always check for extraneous solutions. Extraneous solutions are extra solutions or fake solutions, as I like to call them, that sometimes appear. So how we check for them is we get an answer, we plug it back in to make sure it works. So looking at example A, we're solving this equation. Ideally, we want to get the radical by itself. So to do that, we divide both sides by 6, which leaves us with the square root of x minus 4 equals 8. And then to get rid of the radical, we look at the index number. We know it's 2 because it's not written there, and that is the number we raise our exponent to. So when we raise a square root to a power of 2, the radical and the index number end up canceling out. You're left with x minus 4 equals 64. You add 4 to both sides, and we get x equals 68. Now, we're not 100% sure that's our answer. We always have to check our work. So down here, I check. I'm going to plug in 68 for x in hopes that it equals 48. 68. Let me fix that. There we go. And again, we hope it equals 48. So 68 minus 4 is 64. Square root of 64 is 8. The radical goes away. 8 times 6 is 48. Ugh, can't do math today. Can't do math any day, but here I am. 48. So yes, 48 equals 48. This is our answer. We circle it. Looking at our second example, it is now with a rational exponent. Same process. You have two different options if you want to go about this. Both options get you the same answer. Option 1, you switch it to radical form. The fourth root of 3x minus 5 equals 2. Option 2, you leave it alone. It doesn't matter. Okay? So when you have something raised to an exponent and you want to get rid of it, you're going to raise it to another power, but you're looking at the denominator. My denominator is 4. I want to raise it to the power of 4. Both sides. When I do that, 1 times 4 is 4. 4 times 1 is 4. 4 over 4 is 1. They cancel each other out. 2 to the 4th power, 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Okay, over here would be the same thing. My index number is 4. I raise it to the 4th power. Look, it's the same thing. It gets me the same exact result. It doesn't matter how you go about it. Okay? So again, if you want to switch it to radical form, switch it to radical form. If you want to leave it as a rational exponent, leave it as a rational exponent. So I'm going to go ahead and solve. I'm going to add 5 to both sides. I get 3x equals 21. I divide by 3. X equals 7. Again, I check my work. So I have 3 times 7 minus 5 to the 1/4 power, or you could plug it into the radical form, but I suggest doing the original one because what if you made a mistake? You never know if you made a mistake where it happened. Okay, so 3 times 7 is 21 minus 5 to the 1/4 power. 21 minus 5 is 16 to the 1/4 power. And to the 1/4 power means I'm taking the 4th root of it. So if I wanted to change it to this, I could. I break down 16, 2 times 8, 2 times 4, 2 times 2. I need a group of 4. I have exactly one group of 4, which means it gets to leave as a 2. Oop, I flipped a page. Which means it's 2. So did 2 equal 2? Yes, it did. X equals 7 is my answer. Moving on to example C. I have 5 times the square root of x plus 13 minus 4 equals 46. So from here, I want to do the opposite of PEMDAS, meaning I want to add or subtract first, and then multiply and divide if I can. So I want to move this 4 over first. I see a lot of people that don't like doing that. It makes it more complicated. So save yourself some stress and just move the 4 first. Okay? 46 plus 4 is 50. From here, I need to move that 5 to the other side because ideally I would like the radical by itself. And if we can make it happen, we're going to make it happen. So I divide both sides by 5. I get the square root of x plus 13 equal to 10. My index number is 2, so I'm going to square it to undo it. Again, the exponent cancels out the radical. I'm left with x plus 13 equals 100. 10 squared is 100. I solve for x by subtracting 13 from both sides. I get x equals 87. Again, yes, you have to check your work. You never know when that extraneous solution is going to pop up. So this is me checking my work. I plug in 87 for x. 87 plus 13 minus 4. We hope it equals 46. 87 plus 13, that's 100. Square root of 100 is 10. 5 times 10 is 50. And 50 minus 4 is 46. Yes, 46 equals 46. So x equals 87 is our answer. Looking at our last example. Again, if you don't like rational exponents, switch it to radical form. So radical form will look like the square root of 2x minus 3, and it equals 17. Either way, it doesn't matter. But I'm going to solve it with the rational exponent, so I'm going to raise it to a power of 2, again, because my denominator is 2 of that rational exponent, and what I do to one side, I have to do to the other. The exponents cancel each other out. We're left with 2x minus 3. 17 squared is 289. I solve for x. So I add 3 to both sides. I get 2x equals 292. I divide by 2 on both sides. I get 146 for x. I need to check my work. So I'm plugging in 146 for x. Okay, so 2 times 146, that is a 292 minus 3 to the 1/2 power. Again, we're hoping that it equals 17. 292 minus 3 is 289 to the 1/2 power, which is the same thing as the square root of 289. 289 is a perfect square. It is 17, which matches. So 146 is the answer. Please check out part 2 for more complex equations.